Squares and square roots. Let's start with squares. Let's start with an easy number. How about 1? 1 squared is 1 times 1, and that equals 1. So there you go. That's a number that has its own square as its own square root. Pretty weird. Anyway, let's go to 2. 2 squared is 2 times 2, and that is 4. You've done all these before, so what's the biggest one? The biggest one I can remember is this one, 15 squared, that's 225, and that's, 15 times 15. How about x's? Can you do this with x? Sure you can. X squared is just x times x. And what does that equal? Well, that depends on what x is, so I've got to stop there. So those are squares. Now, what is the inverse of a square? It's a square root. And the square root of a number, we use this little brackety symbol to do it. The square root of a number is what number times itself equals that number inside the bracket. So the square root of 4 is 2. So this ties back to that. And so the square root of 225 is 15. And what's the square root of x squared? That's just x. What if, just to kind of as a side note here, what if someone said on a quiz or something said, what would you guess the square root of 90 to be? If you just had to guess a decimal number off the top of your head, how would you estimate that? Well, you might go in between two numbers. You might go, okay, so 9 squared is 81. Why did I write 80? I don't know. 9 squared is 81. And 10 squared is 100. So maybe you'd think, well, we got 81 to 100. 90 kind of fits kind of in between those two, right around here, So you might guess 9.5. Let's bring up a calculator here, and let's go 90 square root 9.48. Yeah, pretty close. Okay, so what would other graphs look like here? Let's see here. If we pick, if we want to make a graph of any of these, 1 squared, 2 squared, 15 squared, the graph is going to kind of look the same for all of them, because if you pick a number for x, like let's say we pick 2, and we say 2 squared is 4, so this is just going to be a flat line at a height of 4. And so this one is just going to be a flat line at a height of 1, because that's a constant. So that's not really very interesting. That's kind of boring. But if we take the graph of x squared, it gets a little bit more interesting. So we've got this x-axis here and the y-axis here. What if we put in a 1 for x? Well, we got 1 times 1. So if we put in 1 for x, we get a 1 for y. So if I just put some tick marks here, probably not do a great job, but good enough. Okay, but what if we put 2's here, 2's for x's? So 2 times 2 is 4. So if we put in a 2 for x, that's in this neighborhood. So 1, 2, 3, 4. So you get the idea that this graph, and what if we put in zeros? I probably should have started with that. 0 times 0, so we're going to have a dot here. So you get the idea that this graph is going to go, and it's going to go up fast. Let me just do one more example. Let's put in, I don't know, 4 for x. So if we put in 4 for x, that's in this neighborhood right here, and that's going to be 16. So how high did I go here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 16 is, I don't know, probably in this neighborhood up here. So this graph of x squared it curves, that's a crappy drawing, but hey, oh well. It curves upward pretty steeply. But this isn't the whole thing. This isn't the whole graph of x squared, because it does something else. Let me show you. Let me get into Google here, and let me type in graph x squared. And let's see here. I thought Google would do this for me. Graph of x squared? What if I type that in? Huh. Okay, so if you graph x squared, look at this. It goes up on both sides. It's a parabola type shape here. So it does not only what the graph that I was doing did, it goes up really steeply like this, but it also goes over here on the negative side. So why would that be? What's going on? Well, x, you could put in other numbers for x. You could put in, say, -1 for x. And -1 times -1 is +1. So if you put in a -1 for x right here, you get a +1. And so just for giggles, I'll put in 3 for x, -3. So -3 would be somewhere in this neighborhood, I guess. And that -3 times -3 is 9. So 9, you know, is up here. So what you wind up getting is you wind up getting the other half, or the mirror image, of the first side that we did. So this is what x squared looks like as a graph. So I hope at least one kid out there is sitting there going, okay, so there's the graph of x squared, but what would the graph of this look like, the square root of x? Well, all we have to do is plug in a few numbers. So if we put in 1 for x, the square root of 1 is 1, so we're going to have a dot right here. And of course, we're going to have 0, 0 right there. But what if we put in 2? Well, that's not that easy to do in your head. The square root of 2 is 1.4, but that's kind of weird. Let's stick with easy numbers. Let's go 4 for x. If we put in 4 for x, 1, 2, 3, 4, we get this. And the square root of 4 is 2. So we're going to have a dot in this neighborhood. So whereas this graph went over and up really fast, this one goes up and over. Oh, I missed that dot completely. This one goes up. I can't do it. This one goes up and over really fast. So just as a test, let's make sure. What if we put in a 9 for x and do the square root of x? So if we put in a 9 for x, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that'd be out here somewhere. And the square root of 9 is 3. And that's only right here. So yeah, that points at that, doesn't it? So this graph does kind of the same thing this graph did, but it goes sideways. So squaring something, doing the squared thing, that sends graphs through the roof fast. But square rooting things, that kind of puts a lid on it, and that makes it go sideways rather than up. So there you go. There is hopefully a review of squares and square roots and what their graphs look like.